All right. Lightning McQueen versus Jackson Storm, a mathematical racing story. This presentation is going to be about how we deal with distance, rate, time problems when we've got some funky things going on with the race situation. The race in question. Lightning McQueen has been the reigning Piston Cup champion for years with an average racing speed of 80 meters per second. This year, however, rookie racer Jackson Storm is proving difficult to beat with a speed of 90 meters per second. Storm has a huge ego. For an upcoming race, he says that he's going to give McQueen a 2 minute head start and still finish the race 400 meters ahead of him. If this is true, how long will the race take, and what will be the total distance of the race? First thing we want to do is organize our information. So we're going to set up a table where we're recording the rate, time, and distance for each racer. One row for Lightning McQueen, one row for Jackson Storm. We know that Lightning McQueen's rate is 80 meters per second, and Jackson Storm's rate is 90 meters per second. We don't know exactly how long the race takes. We do know that Lightning McQueen is driving the entire time, from the time the race starts until the end. So we're going to say that his time is T seconds. We then also know that Jackson Storm has given Lightning McQueen a head start, which means he's been spending less time driving than Lightning McQueen has. That less time we're going to express as subtraction. So Lightning McQueen's time is T. T minus that 2 minute head start is Jackson Storm's time. But because we're working in seconds instead of 2 minutes, we're going to translate that to 120 seconds. So Jackson Storm's time is T minus 120 seconds. Then we multiply rate by time to get distance. So Lightning McQueen's distance is 80 T meters, and Jackson Storm's distance is 90 parentheses T minus 120 meters. Now, the total distance in the race is Jackson Storm's distance because Jackson Storm is saying that he is going to finish the race and beat Lightning McQueen by 400 meters. So Jackson Storm has driven the entire distance of the race when it ends. The total distance in the race is also equal to Lightning McQueen's distance plus 400, because when the race ends, Lightning McQueen is still 400 meters shy of the finish line. So, however far he's driven, plus that extra 400 meters, is the total distance in the race. Now, since the total distance is the same, regardless of who's driving it, the total distance in the race is Jackson Storm's distance, which is also equal to Lightning McQueen's distance plus 400 meters. And then using the information we had in the table at the beginning, Jackson Storm's distance is 90 parentheses T minus 120, and that is equal to 80T plus 400, which is Lightning McQueen's distance plus that extra 400 meters. Solving this equation, we're going to start by distributing. That gets us 90T minus 10,800 equals 80T plus 400. Subtracting 80T from both sides gets us 10T minus 10,800 equals 400. And then we can add 10,800 to both sides to get 10T equals 11,200 and divide by 10 for T equals 1,120. So the total time in the race is 1,120 seconds. From there, the next question is what about the distance? We have two options for how we could find the distance because we had two expressions for the distance earlier, either Jackson Storm's distance or Lightning McQueen's distance plus 400. We're going to go ahead and use Jackson Storm's distance. So the total distance in the race is 90 times T minus 120. We just found out that the time was 1,120. So we'll plug that in. The total distance is 90 times 1,120 minus 120. Subtracting in the parentheses, total distance is 90 times 1,000, which is 90,000 meters, or 90 kilometers. So to sum up, when you see a problem like this, you start by setting up a table to organize the distance, rate, and time for each racer. Then you use the information about the head start to relate Jackson Storm's time to Lightning McQueen's time. Use the information about Jackson Storm's win distance to get the total distance of the race in terms of both racers' distances. Set the two expressions for the total distance in the race equal to each other and solve. And once you know that time, again, you can plug it back in to one of the distance expressions and find the distance.